Hey guys, I'm going to work out two free body diagrams for you that are in your PowerPoint notes. So this one we are given our friction force, our mass, and our acceleration. Now the steps don't necessarily have to go in the same order that I'm going to show you, but this is generally how I would approach a problem like this. Since I'm given both mass and acceleration, I'm going to go ahead and find my net force. So I'm going to use my F equals AM formula to do that, which is going to be 6 times 0. And anything times 0 is going to give me a force of 0. So my net force here is 0 newtons. So that means my object is at rest or moving with a constant velocity. It also means that all of my forces up here are going to be equal and opposite. So if I have a 15 Newton force going to the left, I need that same magnitude going to the right, and that means my force of gravity and my normal force are going to be the same value as well. All right, so I can go ahead and write in my applied force of 15 newtons now that I know my net force is 0. So then the last thing I need to do here is find my force of gravity, which is technically my F equals ma formula, or your weight formula would also work here. So I've got a mass of 6, and my acceleration due to gravity is going to be 9.8, and that is going to equal 58.8 newtons for my force of gravity. And then again, since our net force is 0, my normal force is going to be 58.8 newtons. All right, so to recap, we found our net force by multiplying 6 times 0 to get us a net force of 0. Because our net force is 0, that means all my other forces need to be equal and opposite. So my applied force became 15 newtons. Then I found my force of gravity using the F equals ma formula, or the weight formula would also work. And that's going to be the same as your normal force. All right, so next one here. All right, so this one we are now given our friction force, our force of gravity, and our applied force, and we don't have mass, acceleration, or our net force, right? With these, you are only going to have your net force moving in one direction. So right here, my friction force is 10 newtons, while my applied force is 50. So since those are not equal and opposite, that means my net force would be going, in this case, to the right, because this is the greater force. I'm not going to have like a net force going to the right and a net force going up. So my net force here, I'm going to subtract those two. It's going to be 40 newtons, and it's going to go to the right. So instead of using my F equals AM formula to find my net force, I'm just subtracting out of my diagram as the other way to do this. Right? This also means that my normal force is going to be the same as your force of gravity, and you will probably catch on pretty quickly that those are always going to be the same. Right? My next step in this problem is going to be to find my mass, and I'm going to use my F equals ma formula, or you can use your weight formula because they're the same. So I have a net force of, a force of gravity is what I'm going to use here. And then I'm solving for my mass, and I am using 9.8 because that's my acceleration due to gravity. So I have 80 equals 9.8 times my mass, and that is going to give you a mass of 8.16 kilograms as my answer. All right. So when you're working these out, if you are given the mass, you are going to multiply it by 9.8 to get your force of gravity. If you are given your force of gravity, you're going to divide that by 9.8 to get your mass. Right? The last step to do here is to find your acceleration, and that you are going to use your F equals ma formula, and all three of these would go together. So you're going to take your mass of 8.16 and divide that into 40. So you get 40 equals 8.16 times acceleration. You end up getting an acceleration of 4.9 meters per second squared will be that answer. So let me write that over here. All right, so to recap, we determined our net force was 40 by subtracting the applied force minus your friction force, and it's going to the right because your rightward force is greater. Your force of gravity and normal force would be equal to each other, giving you 80 newtons for your normal force. We found our mass by taking our force of gravity and dividing it by the acceleration due to gravity, and that gave us the 8.16. And then we used the F equals ma formula by plugging in the 40 net force and our mass, and that gave us our overall acceleration of our object. So, all right, hope this video helped you out.